All right, good morning, everyone. Thank you for coming. My name is Breanna Herbert. I'm with ORBIS Corporation. We have about 20 minutes together to discuss measuring the environmental impacts of reusable packaging and the circular economy using life cycle data. That's probably one of the longest titles I've ever had for a presentation. So I'll try to leave some time at the end for some questions. Feel free if something comes up in the middle, raise your hand, I can answer it on the spot. If not, hoping to have around 5 minutes at the end for any questions that anyone may have. Quick introduction of who I am. My name is Breanna Herbert. I am with ORBIS Corporation. I am a product manager for our industrial plastic products line. So originally started off with our knockdown containers, and then more so recently, I've been the product manager for totes and pallets. And then alongside being a product manager, I am also the sustainability lead on the marketing front for ORBIS Corporation. So we'll dive a little bit into reusable packaging in itself, kind of the supply chain, the manufacturing process for reusable packaging, and then get into some of the calculator techniques that we use at ORBIS that we find very beneficial when measuring the environmental impacts of packaging. So to start us off, why reusables? I think this one, from a first take is pretty easy. First and foremost, it reduces waste. You're not having to utilize single-use packaging such as expendables or wooden pallet packaging. You have something that you're able to use over time after time again and don't have to dispose of it after a single use. Cost savings as well, since you're only having to purchase that one front time with a reusable packaging, you don't have to constantly have to be buying more packaging time and time after again, like you would so with single-use packaging like corrugated or pallets. Also improves efficiencies and standardizes the workflow in the supply chain and helps optimize transportation, which we'll get into a little bit more and how that affects the overall environmental savings with packaging. One of my favorite things that I like to talk about when speaking to reusable packaging is the 3 R's, and then the bonus R, which we'll get into, which is kind of my favorite, the 4th R. But the first is reduce a single-use expendable packaging, which we kind of touched on. And then most importantly, replace that with a reusable packaging system and making sure that you're reusing that packaging system time and time after again until it reaches the end of its life cycle. To really maximize that investment and maximize those environmental savings by the reuse process. And then at the end, once the packaging does ultimately reach the end of its life cycle, making sure that you're able to recycle that packaging. And then the 4th R comes into play with then being able to repurpose that recycled content that you have from the packaging and repurpose it back into new reusable packaging. So that kind of gets into how we utilize our life cycle analysis calculator. So first and foremost, when you are looking at the overall life cycle analysis and the environmental savings that reusables have, it kind of hits on 4 main target areas that we typically see with environmental savings. The first is waste, which is kind of easy to infer. You're reducing the waste of single-use packaging. Water, when you start to think about the overall manufacturing process and how when you have single-use packaging, you have to actually make that packaging time after time again. So that creates a lot of water, energy, and carbon emission savings. Whereas with reusable packaging, you're going through that manufacturing process once, and then that packaging is lasting for years to come. And you're getting rid of that whole entire first upfront manufacturing process, the resource of the actual materials itself. So the corrugated for corrugated boxes or wood for wood pallets. And then also just looking at plastic too as the first resource, and you're kind of scrapping out that first part of the supply chain process. So aside from looking at the overall supply chain of reusable packaging from the start of the manufacturing process of how it's manufactured to the end of how it's recycled, there are a couple of different ways that you can measure the impact of your actual reusable packaging system. Aside from that manufacturing process. So cube utilization for full packaging. With being able to do reusable packaging, whether that's a metal rack, whether that's a tote, whether that's a bulk container, you're ultimately able to get more pieces into that part. And then ultimately, once you're able to get more pieces into your packaging system, that's more pieces on a truck. So less shipments in a truck obviously then equals less fuel and less emissions, which is a carbon emission savings. You also have light weighting. So another benefit to reusable packaging is you have a wide variety of different solutions that you can have for your application, and making sure that you're choosing the right solution for that application. So that could range from anything from a lightweight sleeve pack to a bulk container to a metal rack or a steel bin, and making sure that you're really putting the right application into the right solution. So if you have something that's a little bit more lightweight and doesn't necessarily have to have a durable solution around it, maybe don't put it into a steel container, maybe look at an option of a sleeve pack or a bulk container, and that's ultimately going to lower the weight in your truck, and then less energy that the truck has to go through with transporting that material and the packaging, which is ultimately then less energy and carbon emissions. Collapsibility, nestability, looking at knockdown bulk containers. Also, there's collapsible steel racks out there as well, making sure that when you're doing the return loop and you have empty containers coming back, that you're fully taking advantage of that nestability and the collapsibility with your packaging, so you can maximize the return shipments, and then ultimately not having to, again, use more trucks and more fuel and more emission. And then the next is recycled and alternative types of materials, such as recycled content, which we'll get into a little bit more on the next slide. So when you're thinking about plastics and the life cycle of plastics, and then, again, the manufacturing process of plastics, you do see that initial carbon emissions in the beginning of the life cycle of plastics when you're extracting that oil and that virgin material out of the ground to create essentially plastic pellets. So when you utilize recycled content, you're completely scrapping out that initial process of having to use the oil, the carbon emissions to extract the virgin material out of the ground. So you will see some carbon emission savings with that as well, which is something that life cycle analysis calculators can definitely take into consideration with the overall carbon emissions impact that your material choice that you use in reusable packaging has. So then that kind of gets into more of the fun aspect of recycled material. There's a lot of different variety of choices that you can have with recycled material. The first is your standard recycled content. So when you think about recycled content, it can come from two different sources: post-consumer waste, which is known as PCR. I like to think of this as anything as a water bottle that you yourself are using as a consumer and then are disposing of, and that water bottle can be recycled and then repurposed into something else. We also do classify packaging, so reusable packaging, as technically post-consumer waste. So every single time that you're using a bulk container, tote, or pallet, or even a metal system, metal racks can be recycled and repurposed as well. Whenever you are recycling that and then repurposing it back into new packaging, that would be considered a post-consumer PCR. Then we also have post-industrial plastics, so PIR waste. And this is when you're thinking about your own manufacturing. So if you're a manufacturer of plastic or manufacturing something within your own supply chain and you have a lot of scrap levels there, you can also then use that scrap in your own manufacturing process to then repurpose back into packaging. And so that one you kind of can get a little bit fun, because then it helps in your own supply chain waste, and then you're able to find a home for it back into your packaging. And then the last one is definitely something that's been a hot topic, I would say, within the last couple of years, which is ocean waste. There's different types of ocean waste that you can choose from. There's ocean-bound plastic, which is plastics that's found along major waterways, such as Egypt, Indonesia, typically in third world countries. And it's not technically waste that's in the ocean. It's just ocean-bound waste. Then you also have ocean waste, which is specifically ocean plastic that is in the ocean in waterways, and then is taken from the water itself. So lots of different options that you can choose from when looking into recycled content, and then ultimately helping reduce carbon emissions as well as waste. So this kind of gets into a typical life cycle analysis inputs, kind of taking everything that I just discussed into consideration. So the overall manufacturing process, recycled content choices, the type of packaging that you desire and choose depending on the type of application that you have and the solution that you need. And this gets into the inputs and how you're able to look into the environmental impacts of that choice. So the first one is packaging type. Are you looking to figure out what your savings are going from a corrugated box solution to a tote? Are you looking to understand your environmental savings from a wooden pallet to a reusable plastic pallet? Are you looking to understand the savings from a steel rack to a bulk container? That's definitely something to take into consideration because all will have different types of environmental impacts. And then also looking at the overall supply chain loop that you have with that desired application that you're looking to calculate. Where is it going? How long is it going? Is it going from Mexico to Canada? Is it going from Asia to Mexico? Is it maybe just going from South Carolina to Tennessee and is a little bit more of a shorter loop? Stuff like that. And then as well, just the overall weight of the product being shipped. Are you shipping a bunch of steel containers or are you shipping a bunch of pallets with totes on them with more smaller parts inside? And then the end of life plan. So the recyclability of the product as well is taken into consideration for environmental impacts. So we've done a lot of analysis for environmental impacts. Some of the things that we typically always see when we're looking at an expendable conversion into a reusable conversion, specifically with corrugated box conversion. So this is your small type boxes and your large Gaylord type boxes. You will always see when you're transitioning over into a reusable system, better environmental numbers in all three categories of energy, solid waste, and carbon emissions. Again, that I keep stressing on, this is mainly because you are eliminating the need to have to constantly remake the corrugated solutions or the expendable solution. You're able to wipe out that whole entire manufacturing process that takes a ton of energy, carbon emissions, and waste to make those products time after time again. And then instead transitioning into something that can be reused and doesn't have to be made time and time over again. One thing to note with wood pallet conversions is you typically do see better environmental numbers with wood for energy and waste. However, sometimes we do tend to see carbon emissions being a little bit better, if not equal, from wood to reusable plastic pallet system. And this is because, oddly enough, wood kind of grabs and takes hold of all of the carbon emissions that are harmful to our environment, and it stores it into wood. So that is one consideration to note when you're doing the wood pallet conversion into a plastic pallet conversion, is you still will get that energy and that solid waste reduction, but the carbon emissions conversion and environmental impact isn't necessarily as big as you would see with a corrugated box going into a reusable tote or bulk container. And then this gets us into another overall, how do you kind of compare some of the biggest impacts in the environmental world when we're doing these calculations. So weights, when you're reducing the weight to a truckload, you will see carbon emissions impact with overall weights. However, recycled content, we have found that this makes the biggest amount of carbon emissions impact when you are increasing the type of recycled content in your overall packaging solution. And that kind of ties back to the beginning slide that I had that shows that overall process of recycled content and how virgin plastic is extracted from the earth and having to remove that process. Regardless if you're using virgin material or recycled content material, you're still going to get a carbon emission savings because it's ultimately going into a reusable packaging solution, and that's already environmentally impactful in itself. But just again, recycled content, we do tend to see the biggest impact when looking at the environmental calculations. And with that kind of wraps everything up.